Right, so we have so far done mechanics, electricity and waves. So now we're on to a new part of the course called materials. You already know what this is about?
No. Everything you can.
Okay. Materials. So the first lesson we'll have is density, but you should remember this word from mechanics. Yeah, you remember it? What is density?
Mass over volume.
Yeah. What does it mean though? What's it represent?
It's like how much matter is in this volume,
Yeah.
something like that.
You remember this, Sophie? Do you use this word in chemistry?
Not really.
Do you? Okay. Density, have you got that? So, we've seen this formula for density already in semester 1. Remember that density is mass per unit volume, and the formula, you said it there, what is it?
Mass over volume.
Yeah, mass over volume. And what's the dimensions? It's mass per length cubed, so what's the units? What would be the unit?
Meter.
No.
Mass is kg.
Yeah.
Meter cube.
Right. Say it again fully, full sentence.
Kg per meter.
Thank you. Kilograms per meter cubed. Okay, so I don't need you to write all this down again, but can you just write the formula down again to remind you? But you remembered, which is good. Okay. Right, so, Hareen, as you said, it tells us how much matter is in a particular amount of it. Some materials have high density, for example, gold has high density. The density of gold is 19,320 kilograms per meter cubed. This means per unit meter cubed of volume of gold, there is 19,320 kilograms of mass. Gold. It's dense. How much mass is there per centimeter cubed volume of gold? So what I want you to do for me is a small question, is I want you to work out per centimeter cubed how much gold you have. You understand? Okay, can you try that for me? So you can use the formula if you want, or you can just work it out a different way.
With 1 unit meter cube, then how many kg?
Well, we'll write it down here. So density is mass over volume. So mass is density by volume. So what's the density of gold? What is it? 19320. And Hareen, the volume would be 0.01 cubed. So we got 0.01932 kilograms, or if you want, that is 19.32 grams. So you could say that the density of gold is 19320 kilograms per meter cubed, or you could say it's 19.32 grams per centimetre cubed. That's okay? Yep, great. So, some materials have a low density. What would be a material with a low density?
Water.
That's medium. What would be low?
Helium.
Correct. Helium. So, for example, has a low density. Its density is tiny compared to gold. I mean, gold was 19,000. Helium is only 0.179. It's not even 1 kilogram per meter cubed. So this means per unit meter cubed of helium, there's only 179 grams. It's not much. And you know what helium is used for. Right. So what would be a medium density?
Water.
Water, yes. Something like water. Do you know what the density of water is?
1 kg.
No? Do you know, Sophie? Density of water is 1,000 kilograms per meter cubed. And water. In fact, this value is an important value in science. But that's more of a biology question. We won't talk about that. The density of water is so important, often we give the density in terms of that of water. For example, you remember that gold was 19,000? So we often say that the density of gold, that should say 19, not 16. Not 16. So we often say that gold is 19 times more dense than water. So do you understand what I mean? That because water is so important in physics and science and biology, we usually compare density with that of water. So we say gold is 19 times more dense than water. So we have this thing called relative density. And the relative density, which is S, is a measure of density of an object with respect to the density of water. So that is the density of the object is its density divided by the density of water. You're comparing it to water. So in this example here it's 19 because it was 19,000 over 1,000. And it has no dimension, no units. Okay, so if you just write this down, relative density. Okay, got that? Right. So for example, it's used for buoyancy. Do you know this word, buoyancy? You know it, Irene. Do you know it, Sophie? Explain buoyancy. Go on.
Buoyancy is something like for ships where it's buoyant, where like the mass or volume is above water so it can float.
Oh, you made that difficult. Buoyancy means floating, floating on water. So, for example, a ship has high buoyancy. It wants to float. What has low buoyancy?
A rock.
A rock. It wants to sink. If the S is less than 1, like wood, and then you put it in water, what happens?
Float.
It floats. And if the S is more than 1, like gold, and it's placed in water, what happens? It'll sink. So this is part of the reason this is important, because you can know if it sinks or if it floats. And what if S equals 1? What do you think?
Then it will be in between.
Yeah, what would that mean?
It's floating at
It could be water, yeah. So it'll just kind of mix around in it. Okay. Right, so here are some values of materials for density. So the first one is gold. You have this one already, 19,320. Silver you don't have. Now you need these for the question, so you need to write this table down. 10,500. Nickel is 8,900. Now, look at this. Salt water is a little bit more than water.
Is that why dead bodies float on top of the not fresh water?
Yes, that's true. But what made you think of this?
Because it was in a movie.
Okay, fine, yeah. Do you know, what's it called? The Dead Sea?
Mm-hmm.
Yeah, do you know the Dead Sea? Where is it? It's in Israel, isn't it? No, yes.
Yeah, UAE then.
Yeah, that area there. The Dead Sea has a lot of salt in it, which means everybody will float in it because its density is quite high. Fresh water is 1,000, ice is 916, alcohol is 789, wood is 700, and air is a mere 1.2. Tiny. Why did Amanda and Grace need to go to GNIB today? What were they doing?
Said they had to extend the visa date or something.
Oh, okay.
I think because they were here earlier, right? For intake one. So they only had like certain time.
That's the reason. Okay, you got this table? Yep. Alright. Let's have a look. Let me see. I got 3 questions to do. Okay. Right, so the first one, I'll let you write it down part by part. So part A is to convert 1 litre into SI units. So we'll just do that first. Okay, so just write the first one down. We'll do it bit by bit. So convert 1L into SI units. You got that? No, just the first part, A, yeah? So, what is the definition or the key idea for litres? Well, it's that 1,000 litres should equal what? One.
But that's the,
Right? Isn't that it? 1 metre cubed.
Yeah, oh, it is a chemistry.
Yeah. So anyways, 1,000 litres is 1 metre cubed. Yeah? So then that means 1 litre is 1 over 1,000 metres cubed. So 1 litre is 10 to the minus 3 metres cubed. So that's a litre in SI units. A litre is 10 to the minus 3 metres cubed. Yeah, this is SI. SI is kilograms, meters, seconds, that's SI. Yeah. Yep. Okay. I can continue? Write down the next part. So B part is what is the mass of 1 litre of fresh water? Yeah? Yeah? Okay, so the formula is density is mass over volume. So mass is density by volume. What's the density of fresh water? 1,000. Oh dear, I got coffee on my pad. You haven't got tissue, have you? How did that happen? No? Maybe I have some old paper. My pastry. Okay, so it's 1,000, and then what's the volume of 1 litre?
10 to the power negative 6.
Yeah, so what do you get for the mass here? So it's 1,000 times 10 to the minus 3, so you get 1 kilogram. Okay. So part C now is what's the mass of 1 litre of salt water? Yeah? So 1 litre of salt water, well, it's going to be the same thing, isn't it? So I'll just go straight to the answer.
Salt water is high density.
Sorry, by same thing I mean like the same method. So the mass is density by volume, which is 1030 multiplied by 10 to the minus 3. So you get 1.03 kilograms. Okay, part D. What is the total mass? Well, that's for babies. Sorry, you need to write combined mass. What's the combined mass here? 2.03, yeah. Yeah? So, the total mass is 2.03. What is the combined volume?
It's 10 to the power 8. Yeah, 10 power negative 3 plus 10 power negative
10 minus 3 plus 10 minus 3, isn't it? So it's 10 minus 3 meters cubed plus 10 minus 3 meters, sorry, not meters cubed, meters cubed. So that's 2 times 10 minus 3 meters cubed. Okay. F. What is the combined density? Okay. So, I can do this one? Yep. So look, the total density, total, is the total mass over the total volume. What's the total mass? 2.03. The total volume? 2 times 10 to the minus 3. So the answer will be something like 1.015, is it? Yeah, so the density is 1015 kilograms per meter cubed. Is that okay? Right, let's have a look at the next one. A student places 10 grams ice cubed into a bottle of water. The student okay, so you don't need to write this one down. It's a lot of English and it's just an idea. Okay. The student places 10 grams of ice in a bottle of water. The student closes the bottle of water and there's no free space. So if you want to picture it, it looks like this. So they have some ice in the water and there's no free space. So the lid is on the top and it's closed and there's no space left. The bottle of water is left out and the ice in it melts. When it has fully melted, what has happened to the bottle of water? So you want to pick the 3 choices here. So my question is, when this ice melts, what happens to the bottle? So your first choice is, the volume of the water increases. Since it is closed tight, the bottle breaks. The volume of the water in the bottle remains unchanged. The volume of the water in the bottle has decreased. There is now a little space between the surface of the water and the lid. So your choices are, the volume either increases and it breaks, stays the same, or actually it decreases and now you have some space on the top. So what do you think? A, B, or C?
I think A.
You're going with A? Sophie, you agree or disagree? Maybe A as well? You know what?
What?
It's not. C.
I tried to make sense of it because ice is basically like it's water, but it's water with like the atoms are closer to each other. So when it melts.
Let me explain. Let me make it easy. So let's say the mass of the. You don't need to write this down. Just try to understand, okay? I mean, if you want to write it down, that's fine. But I just want you to understand. So let's say the mass of the water is mW, and the mass of the ice is Mi. Okay. So at the moment, the volume is equal to the volume of the water plus the volume of the ice. Density is mass over volume. So what is volume? Mass over density. So the mass of the water over the density of the water plus the mass of the ice over density of the ice. Now, when the ice melts, okay, so the masses don't change, agreed? It's still mass of water and it's still the mass of the ice. True? The water doesn't change, it's still density of water. But when the ice becomes water, what happens to the density of ice? It becomes the density of water. When the ice melts, this is the water and this is the ice. This stays the same, but the density changes from, what is it, like 915, and what will this become? 1000. So, if this part here gets bigger, what happens to the fraction? Smaller.
The denominator will be bigger. I mean, yeah.
No. The only thing that, if the bottom becomes bigger, then the total becomes smaller. And if you add these together, what happens to the total? If the first one is still the same, it's smaller. So this gets smaller. So this volume decreases as the ice melts. So the answer is C. You have more space in the bottle.
Can we test it?
You can test it. Absolutely, you can test it. If you put ice in a cup and fill it with water to the very top and leave it out, after it melts, the water level should drop a little. Can I continue? Sophie, is that okay? Yeah? Alright. Okay, write this one down. It's our last example. Okay, you got this?
Not yet.
Do you have any jewelry, Hareen?
Not now.
Not now?
Not here.
Sophie, you have any jewelry on you? No? So, do you have any at home? Yes. So, you all know what silver is. I've got some silver here. But sometimes, to make the jewellery cheaper, the silver is mixed with nickel. Nickel is cheaper than silver. And when you mix silver and nickel together, you can know that it's mixed together because the density is different. Let's calculate the density when you mix 10 grams of nickel with 1 gram of silver. Let's see what you get. Okay, so firstly, I'll write density of the mixture. That's the mass of the mixture over the volume of the mixture. What's the mass of the mixture?
11.
0.011 over the volume of the mixture. So far okay? This will be 0.011 over the volume of silver plus the volume of the nickel. Now, how much do you have of silver and nickel? Well, remember, if density is mass over volume, then volume is mass over density. So this will be 0.011 over silver. We had 1 gram, wasn't it? 0.001 over the density of silver plus, and then for nickel it's 0.010 over density of nickel. Okay, do you have your table, Hareen? Right, can you tell me then what the density of silver is?
10,500.
Okay, and then the density of nickel?
8,900.
Right, so let's see what the density of the mixture is. 9025 kilograms per meter cubed.
Okay, like a lot.
This much?
Yeah.
Well, that's everything.
Yeah.
Okay, Ken? No, you don't have it yet. So, Hareen, if you don't have enough money to buy silver, you can buy nickel silver jewellery for your friend.
Okay.
Just advice.
Thank you.
No problem. I want to make physics useful for you. Okay. You got this?
Mm-hmm.
Yes? Yep. Alright. So, I've seen, by the way, I've seen this question in section A maybe 2 years ago. So this is the type of question you would get in the exam for density. Okay? And this one here is not really an exam question, and this one here is too easy for the exam. So it's like this in the exam, okay? Right, here are your questions. If you want to take a picture of it, I'm going to upload the video to YouTube. I'll do it now, actually. Okay, got that?
Mm-hmm.
Yep. Right. Now let me just have a look here at what our next topic's going to be, if it's big or small. Small. We'll do the next lesson as well. Okay, let me close.